Hi, good morning. Today we are going to explain the function of separator. Separator is a polymeric membrane, okay, that is placed between anode and cathode. And the function of the separator is to insulate from electrical perspective the anode to the cathode. But the separator is not just a classical plastic membrane of polypropylene or polyethylene, but is an engineering structure membrane with a very small pores which allow the ionic transfer from the cathode to the anode during charging and from the anode to the cathode during discharging. So the separator function is to insulate from electrical point of view anode to the cathode, and the meanwhile allow the ionic transfer from the two electrodes. The separator must have some KPIs, some properties, in order to allow a very good functionality of the batteries. Okay, first of all, we need to start from the raw material. Okay, the separator is made of polypropylene or polyethylene, or a mix between polypropylene and polyethylene in 3-layer separator structure. The difference between the two materials is that polypropylene has a very high melting temperature, okay? And for polyethylene, this is a low melting temperature, okay? And later on we are going to explain the difference and why this difference in terms of melting temperature could be very useful for separator's safety. Okay, first of all, we need to classify the properties of separator. We can start with thickness. The separator thickness can vary from 6 to 20 microns, okay? Usually the very thin separator is used for cylindrical cell, and we are talking about, for example, in cylindrical, and we're talking about from 6 to 12 microns, okay? If we move to prismatic and pouch, the thickness can vary from 12 to 20 microns. Everything depends on the manufacturing process. Okay, for sure, laminated product needs very thick separator compared to Z-folding product. Okay, so the first property is the thickness. Okay, the second property is the Young modulus, okay, that we can call E. Okay, the Young modulus have a very important function. A very rigid, okay, separator can be processed in very high speed application and in all application which require a lot of mechanical tension. Okay, for example, if you're going to use separator for winding cell, so for cylindrical cell, during the winding cycle the separator tension change a lot. Okay, so usually during the acceleration phase of the winding cycle, the tension applied to the separator increase. If the tension increase and the Young modulus of separator is not high enough, even the separator structure will be modified by the tension. What does it mean? That means that the pore size increase with the tension, okay? So inside our wound element, inside our jelly roll, we will have different area of separator with different properties, okay? And let's remind that the porosity, okay, the porosity affect the ionic transfer, okay? So the porosity affect the ionic flow capability, okay, and even the internal resistance, okay? So I have a strip of separator inside our wound element with different porosity results in different solid interface layer, okay, due to different ionic flow capability of the separator.